This is our 5th video for Chapter 1. This is Chapter 1, Section 5, Rational Numbers. What you'll learn in this video is to compare and order rational numbers. And remember, a repeating decimal never stops, but the digits have a pattern. A terminating decimal stops eventually. You have one term to define in this video, and that is rational number. When you see it, be sure to pause the video and write the definition in your notebook. Rational numbers are part of everyday life. You see them on price tags, highway signs, and charts. Rational numbers can be written in different forms. To compare rational numbers, it is easier to convert them to the same form. So a rational number is a number that can be written as a quotient of two integers, where the divisor is not 0. Examples are 2 over 5, 0.3 repeating, -6, and 3.5. So every integer is a rational number, but not every rational number is an integer, because remember, integers are only whole numbers. Rational numbers can be parts of numbers, or fractions, or decimals of numbers. Now let's look at an example of comparing rational numbers. So we're going to compare 1/2 and 3/4. So if we look at it on a number line, we can set up a number line and just have all of our lines on our number line be fractions of 1. So we have -1/4, -1/2, and -3/4. If we plot those on our number line, we can see that -1/2 is closer to 0, so -1/2 is the bigger of the two numbers. So since -3/4 is farther to the left on the number line, it is the lesser number or the smaller number. So -3/4 is less than -1/2. Another way to do it is to rewrite the numbers. So -1/2 would equal -1 over 2, and then -1 times 2, and 2 times 2, so the least common divisor is 4, so you write the equivalent, least common denominator is 4, you write the equivalent fraction of 2/4 equals -2/4. So if we're looking at both fourths, -2/4 and -3/4, since we're going negative, a 3 is an even smaller number, so -3/4 is less than -2/4, so -3/4 is also going to be less than 1/2, because 2/4 is the equivalent fraction for 1/2. Another method you can use is if you simply do the decimals, because if you remember the chart from the previous video, 1/2 is the same as 0.5, and 3/4 is the same as 0.75. So if we were going to do this on a number line, -0.5 would be closer to 0 than 0.75. So again, 0.75 would be less than 0.5 if they're both negative. Pause the video and do this quick check in your notebook. You can either use the number line, equivalent fractions, or decimal forms of your numbers. Be sure to use the less than, equal to, or greater than symbol in your answer. Now we're going to compare decimals. So if I have -4.4 and 4.7, well, -4.4 is going to be less than 4.7 because it's negative, where 4.7 is positive. So any negative number is going to be less than a positive number, no matter how big the digits are. If one is negative and one is positive, the negative number is always smaller. So now let's compare it if they're both negative. So -4.4 and -4.7. So if we plot those on a number line, -4.4 is closer to 0 than -4.7. So 4.4 is greater than, or -4.4 is greater than -4.7. since negative 4.4 is to the right of negative 4.7 on the number line. Pause the video and do this quick check in your notebook. Be sure to write the original digits and use greater than, less than, or equal to in your answer. Now let's look at ordering rational numbers. The peaks of 4 mountains or seamounts are located either below or above sea level as follows: 1/4 of a mile, negative 0.2 miles, negative 2/9 of a mile, and 1.1 miles. So which list shows the order of numbers from least to greatest? So the first thing you're going to do is either change them all to decimals or make them all fractions. Most of the time, unless they're very easy fractions and it's easy to see what those fractions are going to be, it's almost always going to be easier to change them from fractions to decimals. So we're going to order these numbers from least to greatest: 1/4, negative 0.2, negative 2/9, and 1.1. So we're going to start off converting them all to decimals. So 1/4, we know from our previous chart, the decimal of 1/4 is 0.25. You can also do the long division if you don't remember, but that's a good one to just learn and remember that a dollar is made up of 4 quarters, and a quarter is 25 cents. So 0.25 is 1/4 of a dollar. It's also 1/4 of any whole. Then negative 2/9 is negative 2 divided by 9, which when we do the long division gets us negative 0.2 repeating. So that would be written as negative 0.2 with a bar over the 2. The other two numbers are already decimals, so we can use a number line to order all 4 of those numbers. So negative 2/9 is negative 0.2. Negative 0.2 is our smallest number. Well, really, negative 0.2 repeating is going to be our smallest number because it is going to be 0.2222222, whereas the 0.2 we already have terminates. So 0.22 is smaller than just negative 0.2. So negative 2/9 is ever so slightly smaller than negative 0.2. Then positive 0.4 goes at 1/4 or 0.25, so halfway between 2 and 3. And then our last number of 1.1 goes farther up. It's the only one that is more than 1 in either direction. So our order from least to greatest is negative 0.2 repeating, then negative 0.2 terminating, then positive 0.25, lastly positive 1.1. So the correct answer is C, once we put everything back into their original forms. So negative 2/9, then negative 0.2, positive 1/4, and positive 1.1. Pause the video and do this quick check in your notebook. Remember, you are ordering from least to greatest. Now let's check your understanding. Be sure to label it as check your understanding in your notebook, number all your problems, write down the original equations, and show any and all work. Enjoy the rest of your day, and I'll see you tomorrow.